is m dot. M dot at any point, right? At any point is the same. So we are going to use the IGES equation, which is equal to PV equal to MRT. So m dot is equal to PV over RT. And because this is a mass flow rate, then we need to put right here as the volumetric flow rate. And the only state that we have the volumetric flow rate is at the free air condition, which is P and T. So we are going to use this condition P and T. We could also use right here as P1 and T1 if we know what is VA minus VD dot. Okay, if you know what is VA minus VD dot, VA dot minus VD dot, then we could use here as P1, T1. But right now, we don't have any data saying that how much is the inducted air in terms of VA minus VD dot. What is given right here, it is FAD, which is equal to V dot. Then we use this formula. Okay, and the unit we want is in kilogram per minute. Then we maintain the V dot as meter cube per minute. Then when you put all the values, the given right here, the R value, then from here we are going to get, can you calculate how much you get? If you try, how much you will get?
$5.88.
Give me 4 decimal point.
8827.
8827. This is in kilogram over minute. Okay. And then number 3 is to get the delivered temperature. Okay, that is T2. What is T2? T2 is equal to T1 P2 over P1 N minus 1 over N. Get what is your, remember just ingat this T2, we get the T2 from the delivery condition. Okay, so if you look right here, the beginning of our compression process is at T1. Okay, here is T1. Normal mistake that student did is the P1 they put as T, as P. If you put the value of P 101.3 rather than putting 97, then it is wrong. Because always load the T2, basically the process from A to B, which is the compression process. Okay, the compression begin at P1, T1. It's not begin at P and T, but it's P1 then T and T1. So you need to use T1 right here, okay, not T. And also for the P, you use P1, not P. Unless if the question tells us that this condition of end of induction stroke and the ambient or the surrounding or the free air delivery condition, they are the same. Okay, but as far as the formula is concerned, this is the formula. Okay, can you calculate for me what is the value of T2?
216.
The question asks, alright,
Celsius, right?
Celsius, right? So this is, you will get,
I get 216.
firstly, you will get in Kelvin, right? And then you will equate each degree C, so you get 216. Point berapa?
0.2.
Alright. Okay. So you get, from this formula, you are getting Kelvin. Then you convert So Celsius because the question asks for Celsius. Okay, please always put the unit what is being asked. And then number 4 is the IP. So what is the formula of IP? The indicated power is equal to, what is the formula? Guys, what is the
N
formula? N
over N minus 1
over N minus 1
M dot
M dot
R
R
R
and
T2 minus T1.
T2 minus T1. So if you look the method what is being asked to you is usually, or it make you easy, okay, because it's already asked for the M dot. This is from 1. Already asked for the T2. This is from, sorry, this is from 2. This is from 3. Okay, so you just put in all the value, but make sure that the M dot you convert to, you need to convert this to kilogram per second. And because part 2 is in kilogram per minute. Okay, so can you calculate for me what is the value of that?
To 2.08 kilowatt.
2.08. Okay, 1 kilowatt. Right? So that is for number 4. And lastly, for this question is asking for the volumetric efficiency. Okay, for this case or this type of compressor, what is the formula of volumetric efficiency? The definition is based on M divided by Ms. Can be proven as V naught divided by Vs. Okay, and then we elaborate on the V naught. So what we have, sorry, this is not V naught, but this is your V. So when we expand the V and Vs, what do we have right here? What is the final equation for volumetric efficiency? So this is the from the definition. Okay, this is from the definition. This is, we try to convert in term of V. From the definition, we try to convert in term of V over Vs. Then when we put all the value regarding the M dot, the VA minus VD, so what is the final formula for volumetric efficiency? Anyone? The final formula for volumetric efficiency for our case? Guys? Formula please, formula.
VA minus VD
VA minus VD. Next.
over VS
Over VS. Next.
Times with P1 over P.
So P T4. This is why we need this, because we have variation of the free air condition and towards the end of induction stroke. So you need to put this TO, P and T4. Actually the T4 we don't need to put the knot. Okay, but earlier version of the textbook that we use, they used to put this as T naught and P naught. Okay, but the version that you have right now that you get from my website is basically is P and T, but I still remember the T pole because it's easy to remember which one is on the top, which one is the bottom, towards the bottom part. Okay, because you know topi dekat atas, right? Topi dekat atas, so topi, tipo. This topi and tipo is given, right? So what we have to do is we have to convert the VA minus VD in terms of VS. So what is VA minus VD? Is there any RPM given right here? This no RPM. Okay. So what is VA minus VD? We need to solve the VA minus VD. Okay. We need to solve the VA minus VD.
Use MRT, sir.
Pardon?
PV MRT.
PV equal MRT. So if we need the VA value, the VA minus VD in term of value, then we use PV equal to MRT. So this is equal to MRT over P. Okay. So if we look at the PV diagram, the VA minus VD is at the P1 and T1. Okay, P1 and T1. Is there any, in this question, is there any speed given?
No, doctor.
No. There is no. Alright, it's okay. It doesn't matter. Because we are not going to use the value itself. We are going to look in terms of per cycle. Okay, we are going to look in terms of per cycle. So this is VA minus VD. And this should be 1, 1. But if we are look here, we need to get this m dot in terms of per unit cycle. Okay, per unit cycle. What we have right here is m dot, meaning that in this question there is no given the RPM in order to convert per unit time to per cycle. So what we have to do in this case, we need to rewrite the VA minus VD in terms of VS. Then we are going to cancel off this VS and also the term of VA minus VD in terms of VS. So this one, okay, question mark. It couldn't get in terms of value. Okay, same goes for the VS. We don't have any value of VS. So in this case, we need to convert VA minus VD in the function of VS. So what we have right here, what is VA? From the PV diagram, the VA is equal to VS plus VC. And given right here, the VC is given as 0.05 VS. So in this case, we are going to get 1.05 VS as far as VA is concerned. Then we are going to look at the re-expansion process from C to D. Okay. Then what are we going to have right here is to look the P, V, okay, power of n equal to P, V power of n. At C, the P is 1. Sorry, this is, we want to get the VD, so I need to put this as VD. Okay, this is P, the VD is at P1. And then if we look at the C, so this is our clearance volume and the pressure involved is 2. So from here we will get what is the VD. Okay, so VD is equal to VC P2 divided by P1 power of n. And we put the VC in terms of VS. And this P2 is 720 divided by P1. P1 is 97. And this n is 1.3. What is that? Yes, what is that? The VD?
Doctor,
Yeah.
1 over n or n only for the
This,
untuk compressor.
oh yeah, sorry. This is n, is 1 over n. 1 over n. Okay, 1 over n. Thank you.
Zero 0.2337 VS.
0.2337 7
Yep.
VS. So once we have solved for the VD and also the VA, then we could write here the VA minus VD. VA minus VD equal to VA is a 1.05 VS minus 0.2337 VS.
Zero 0.8163.
0.8163 VS. Okay, so from here we are going to use the volumetric efficiency equation that we have written before this. So the volumetric efficiency equal to VA minus VD, which is a 0.8163 VS divided by VS to P. The T naught is 300. You need to convert this in Kelvin, yeah. To P, T4. The T1 is 308. So P1 is 97. And P4, P naught is 101.3 times 100 to change in terms of percentage. Okay, how much is that? So the VS will be cancelled off.
76.13%.
76.13. Okay, thank you. Right. I add more question to this. Okay. Let's say this is question that is question number what? Just now we did volumetric efficiency. Number 4, number 5. I add number 6. Get the P ISO. What is the formula for P ISO? The formula for P ISO.
MRT1 ln P2 over P1.
M dot RT1 ln
P2 over P1.
P2 over P1. T1 or T?
T1.
T1, okay. Now, please remember, this is assuming that the compression is done isothermally. So the beginning of the compression process always at state 1. So it's T1. Okay, can you get that for me? How much? So this is number 6. Put all the value. You need to convert this as in kilogram per second. And after that, you, of course, you need to get what is the isothermal efficiency. Okay, what is the P ISO?
P ISO over IP.
No, this one. I need to know this. The value of P ISO. Yes, anybody? P ISO?
Seventeen
17
point four.
4 kilowatt. And what is isothermal efficiency? This is P ISO divided by IP. So we have the P ISO as 17.4, and just now we have calculated for the IP, and the IP is 22.1. 22.1 multiplied by 100 to change in terms of percentage, then you get the value.
78.73.
78.7
78.
78 point
Yeah. 73.
73. Okay, betul 78.73. Huh? Guys, betul
Yes, sir.
Okay, thank you. Yeah. Then I add up one more. What do you think I can add up? This is the possibility the question will ask you. What can I add up more? What do you think? I have asked you about the PISO. I asked you about the isometric efficiency. What else that I can ask you?
Work.
Work of what?
Power from the motor.
Okay. P motor. P motor. Why do we have P motor? What cause the P motor is different from the IP?
Mechanical efficiency.
Yes, we have the mechanical efficiency. What is the definition of mechanical efficiency in this case? The desired output, which is our IP, divided by our required input, which is the P for the motor. So if you have your, let's say, given the mechanical efficiency in terms of, let's say, it's 95%. So meaning that this is 0.95. Or the question might tell you the energy loss or the work loss. Okay, the work loss due to friction. Maybe we have gearbox in between the motor and the compressor. So we have work loss due to friction is estimated. Okay, usually we use this term. Is estimated to be, let's say, 5%. Okay, so if this is the statement made about the work loss, then what we are going to have, we are having the same mechanical efficiency at 95%. Right? So from here you can get your P motor, which is the P motor must be larger than the IP. So P motor is equal to IP divided by P motor. Sorry, IP divided by mechanical efficiency. Mechanical efficiency. Okay. What else that you think I can add up? Menai. I can add up assuming, okay, the free air condition same as the induction condition. What is the meaning of this? Assuming the free air condition is same as the induction condition. What is the meaning? Anyone? What is the meaning of this? Assuming the free air condition same as the induction condition. Anyone? What is the meaning of free air condition? This is
P equals to P1.
This is PT, and this induction condition is P1. So based on this, okay, you can be asked to get all over again. Yeah? You can be asked to get the IP. You can be asked to get the volumetric efficiency. But in this particular case, I want to ask you only one parameter, which is the volumetric efficiency. If this is the case that we have, what do you think the volumetric efficiency will be? Okay, guys, how much is that? If we assume the volumetric efficiency,
Higher, sir?
yeah, the value. You know that the VA minus VD divided by VS, correct? This is tau P T O. So if they are the same, meaning that cancel off. So what we have that here is VA, only VA minus VD. So we have already defined the VA minus VD just now, which is 0.8163 VS divided by VS times 100. Then we are going to get as the 81.63%. Okay, without looking at any or without using or writing any extra calculation. So from here we could get the new volumetric efficiency of this condition, whereby the P equal to P1, T is equal to P1. Okay, guys, any question regarding this test, past semester test question? Ada soalan tak? Tak ada. You guys, any question?
No, sir.
No,
No, doctor.
So if no question, we go to the next set of the past year's semester's question, which is the test 1, okay, test 1, 19-20-02. So this is test 1, 19-20-02. Okay. A single stage double acting air compressor with stroke length to bore diameter ratio of 1.2 operates at 1000 RPM to deliver air at 25 bar in free air condition of 1.013 bar and 27 degrees C. Due to valve opening and heated cylinder wall, the induction condition are 1 bar and 40 degrees C. The index of compression and expansion and the clearance volume are 1.3 and 3% of the swept volume respectively. Given the swept volume is 0.004 meter cube, draw a related PV diagram with appropriate label and calculate. Okay. So what do we have to do next? After reading the question, what are we going to do? Anyone? What are we going to do next? Any suggestion? What are we going to do after reading the question?
Sketch.
Sketch what?
PV.
PV. straight away PV.
No, sketch the piston.
We sketch it's possible we sketch the schematic diagram and we try to look at our cylinder, okay, our cylinder, where are these parameter actually given, okay? And remember, you must take note that this is a double acting air compressor. Meaning what? Meaning what?
Double piston.
Not double piston, double acting. It's single stage, only one piston, but it's double acting.
Atas bawah.
We have two delivery in one rotation. Okay, we have two delivery in one rotation. Okay, faham eh? So if you want to sketch the whole system, meaning that what we are going to have two cylinder head. So this is the piston. So this is our coordinating rod attached to our motor. This is the rotation. And then we have induction. We have induction. And we have delivery. We have delivery. And usually this delivery will be combined and deliver to the accumulator or to the tank. Okay, this is our tank. This is our delivery, the tank. The air after the compression will be accumulated in this tank. And then remember, meaning that we have clearance volume right here. Clearance volume right here. Okay, so two intake, two delivery. Alright? But what is being stated right here, or the approach that we are going to use, is we are going to assume, analyze for only one side. Okay, for only one side. As for the double acting, it will only affect to our IP. Okay, to our IP. We look after this. How do we try to relate? Okay. So now, let's say this is our free air delivery condition. So the free air delivery condition, for sure, we are going to look at T and P. Okay, T and P. So if we look carefully, we have different condition of this free air and also the induction condition. So for this case, different condition of PT. So we have PT right here. I will only look at one side. And we have the P1, T1. And we have P2, T2. Okay, I only look at one side. Okay. Now, we can put all the parameters given. Bore diameter ratio 1.2. Okay. Length stroke. Length of stroke. We know that the bore D divided by length of stroke L is given as 1.2. It couldn't be this. Usually the L will be longer than D. Oh, sorry. Yeah, I'm the one who put the wrong figure, wrong equation. This is a stroke length L over D is equal to, let me put the normal symbol. L over D is 1.2. And the speed of this compressor is 1000. Okay, and to deliver 25 bar P2, 25 bar. In free air condition, P 1.013 bar and T is equal to 300 K. Due to valve opening, heated cylinder wall, actual induction condition, which is P1, 1 bar, and T1, 40 plus 273, how much is that? 310, 313. Huh? Berapa? 313? 40.
Yes, sir.
313, sir.
313 kan? 313 Kelvin. Okay. And the index and compression N 1.3. And given the VC is equal to 0.03. Sorry. 0.03 Vs. And given the swept volume, Vs equal to 0.004 meter cube. Okay? So now we are going to sketch the PV diagram. We have converted all the parameters as our usual symbol. Now we need to sketch the PV diagram.
Sir, 000.
Mana dia?
000. 0.00.
Oh ya, dia punya VS ya. Okay, thank you. 0.004 meter cube. Okay. Now we sketch the PV diagram. So we need to put remarks right here for one side of the cycle. Okay, kita tengok satu saja. We are not going to draw the both cycle for both side. Only one side saja. Dia lukiskan only one side saja. So this is P, this is V. Delivery pressure, induction pressure. Okay. So this is our re-expansion process. This is our compression process. Our delivery, our induction. Okay. A, B, C, D. Alright. P2, P1. Direction of the process. And the polytropic process for this, the expansion and compression. Cause so let us complete. This is our VC. This is our VA. This is our VD. And from here to here is our VS. Okay, and from here up to here, this is VA minus VD. Okay, so the most important thing is this part. You must know where is VS, you must know where is VC, VD, and VA, and you must know where is VA minus VD. Okay, so this is our schematic, the PV diagram. Okay, so what's next? Answer the question. Induced volume at free air condition. Induced volume at free air condition. What is the meaning of that? Induced volume at free air condition. Where is the induced volume? From this diagram, which part is the induced volume? Guys?
VA, VD.
VA minus VD. That's right. So, induced volume is a VA minus VD, which is equal to we might have this VA minus VD in terms of VS, right? Remember? Yeah? We need to know this. What is VA minus VD? When we know that the VA minus VD can be written as in terms of VS. Why we need to put in terms of VS? Because the VS is given. The VS is given. So, if you could remember, right, the term of VA minus VD, okay, the term of VA minus VD, in this case, VA minus VD, we can see this formula from the tau P T 4. Remember that from the volumetric efficiency, don't copy this. I just want to show you. Remember this? This is equal to V divided by Vs. Okay, this is equal to V minus Vs. So if we look here, the term of this, the whole term of this is actually our V. Okay, it's actually our V. Right? So if you compare this, then we could get what is the induced VA minus VD. But if you see the unit that we want is for per cycle. Okay, per cycle. So now we try to get this VA minus VD in terms of Vs. What we have right here, VA. VA as usual, VA is equal to Vs plus Vc equal to Vs plus 0.03 Vs equal to 1.03 Vs. Okay, and what is Vd? Vd is equal to Vc P2 over P1 1 over n, which is equal to 0.03 Vs. What is P2? 25 bar. What is P1? 1 bar. Is that correct? 25, yeah, 1 bar. And the exponential, right, 1.3. What is that? What is that? VA, VD?
0.3568 Vs.
Vs. So now we can write VA minus VD is equal to 1.03 Vs minus 0.3568 Vs. What is that?
Zero point 6732
0.6732
32
Vs. Therefore, VA minus VD is 0.6732 multiplied by Vs, 0.0004. Okay, how much is that? The question asks for the unit of meter cube. Okay, how much is that? 0.00
2693.
How many zero? 30 or 20?
30.
30
20.
to, huh?
30.
Okay, 30 to 6
93.
93 meter cube. So that is number 1. Next question. Free air delivery. Free air delivery. Number 2. Okay, so based what I have written just before this in terms of the volumetric efficiency, so the free air delivery, which is the V. And usually for free air delivery, we are going to get it as meter cube. Okay, as meter cube per minute. Make sure free air delivery. The free air delivery, which is equal to the V dot. Okay, V dot. You see, let us look. Betul tak dia punya unit? Yeah, meter cube per minute is equal to the V dot. And this V dot, we want to convert from V to V dot. What we do, the V time the N. Okay, V time N. And if you can remember, this is a double acting. Okay, this is a double acting. So because this is a double acting, meaning that the free air delivery, we have 2 free air delivery. What we are looking right now is only for one side. So we have to multiply this by 2. This is also by 2. Okay. So the free air delivery, we are looking, the VA minus VD is only for one side. And the question tells us that this is a double acting, meaning that we have 2 air delivery. Free air, we have 2. So how to get the V, the N is given. So now we are going to get the V. The V is equal to VA minus VD multiply by tau P and T po. Okay, remember that I told you just now, the volumetric efficiency is equal to V divided by Vs, which is equal to, so this is the V. Okay, this is the V part. Right? So this is equal to VA minus VD. This is the value. 0.002693 multiplied by T. T is 300, correct? This is 313, if not mistaken. Check for me. The P1 is 1, P0 is 1.013. Let me see back the data. Okay, P 1.3, okay, 1 bar, 300, that's right. So what is that? Yes? Ya guys, berapa?
0.0002548.
2548
Yep.
Therefore, our FAD is equal to 2 multiplied by the V, which is 0.0002548 multiplied by the speed, which is 1000. Do we need to change the RPM to RPS? Do we need to change the RPM to RPS, the speed? Yeah, let's check. 2 have no unit. This is a meter cube multiplied by 1/minute. The answer for free air delivery is in meter cube per minute, meaning that we don't have to convert the 1000 to RPS. So we leave it as RPM. Okay, rotation per minute. Okay, what is that? What is this?
0.5
0.5
0.5096
5
096.
0.96. The unit is in meter cube per minute. Okay, so this is our answer for FAD. So we go next for number 3 is to get the IP, the indicated power. As usual, what is the formula? N over N minus 1 M dot R T2 minus T1. Okay, remember, this is our V dot. Okay, our V dot. Equal to free air delivery, that is the value. And please bear in mind, this is for the double acting. The free air delivery of this is for the double acting. And not for the single side, for double acting, because we have multiplied by 2. Right here. We have multiplied by 2 sides. Okay, 2 sides. So in this case, we have to get the M dot. So what is M dot? We have already the V dot. Therefore, the M dot is equal to PV over R T. This M dot, do we need to multiply by 2? Do we need to multiply this M dot by 2?
No.
No. If we use this value, okay? If we use this value of V dot, we don't need to multiply by 2 because we have did it before. So we just get the M dot based on this V. And we are going to use the P and T, which is the free air condition. Because this V dot is at free air condition. So what is our free air condition? 1.013 bar. So how to convert bar to kPa? How to convert bar to kPa? How to convert bar to kPa?
Jarak 100.
Jarak 100. Okay, good. Jarak 100. Converting bar to kPa. Right? And then the V dot is 0.5096. This is in RPM, so we need to get this in terms of RPS because m dot we need to get in kilogram per second. And then we divide that by R. R is given as what? 0.87. Betul kan? In the question, R is given as what? Check. R tak pergi Ada R. There's no R. Okay. So assume the R is 0.287. Ya, Amirul, nama Amirul, ada masalah apa Amirul? Amirul? Okay. And then the T is at 27. This is 300. So get the m dot. Yes. Berapa? M dot?
Zero point zero zero 9993.
Huh? So,
0.009993.
can someone verify that?
00999.
0.0, sir.
0.01.
0.0, what, 999.
Three zeros. Betul eh?
Tu.
And then
zero.
nine
Double zero.
double
Double zero. Doctor.
Double zero, sir.
99
999.
999. Is it? Kilogram over second. Okay, so get what is the IP? Oh, before that, we need to know what is T2. T2 is equal to T1, P2 over P1, n minus 1 over n. Okay, our T1 is 313, remember? 25 divided by 1. 0.3 divided by 1.3. Ya, berapa? Itu. And also get your IP.
Six five 657.88.
657.9.
0.9.
Okay. IP.
4.286.
4.286 kilowatt. Right? So this is the IP. And then the next question is to get your volumetric efficiency. If you're for the as far for the volumetric efficiency, okay, you can see for both sides or for a single side. The volumetric efficiency will be the same. Volumetric efficiency is equal to V divided by Vs. So we have already the V value for one side. Okay, the one side for V value is 0.00. This is V value. Zero 0.002548 divided by your Vs is 0.0004 multiplied by 100.
63.7%.
63.7%. Okay, thank you. And then after that, you add up more. What can you add up? Tambah untuk P-ISO. Tambah untuk thermal efficiency for P-ISO. Tambah untuk mechanical efficiency. Then you get your P-moto. Okay? So try to continue with that. The next question, part B. Is part B. Explain how the actual induction pressure explain how the actual induction pressure and temperature affects the induced volume at free air condition. Okay, the induced volume, meaning what? The induced volume is referring to the VA minus VD. The effect of what? The effect of actual induction pressure and temperature. So in our case, okay, the induction pressure and temperature at free air condition. So the VA minus VD, okay, let me see how explain how the actual induction pressure and temperature affects the in the induced volume of free, okay, the induced volume of free air condition. Sorry, it's not VA minus VD. Okay, it's not VA minus VD. If the induced volume at free air condition, then that should be your V. Okay, your V. So we are going to look the effect of this variation of PT and P1T1 on the V. So we can look here from this equation, VA minus VD multiplied by tau P and T0. This is the induced volume at free condition. This is the effect of the induction pressure and temperature. So this is induction temperature, induction pressure. Okay, so you need to look at this equation and you comment on the pressure and temperature. What happened when the actual pressure and temperature induction, which is a P1 and T1. So you have to look at this P1 and T1. What happened when you increase the P1? What happened? You are going to decrease the P1. But what the actual condition should be, you always comment on this. Okay, you know that the P1 is always less than the P0. And your T1 should be always then, sorry, not, this is only T. Okay. And then your T1 is always greater than your T. So you look the variation of this P1 and T1. What happened when P1 decrease lower? What happened to T1 when it increased higher than T? It cannot be less. This condition cannot be less. Okay, this must be fulfilled. The P1 is always less than P and the T1 is always greater than T. So you make sure that when you comment on this, look what happened when P1 decrease. And as far as the T1 is concerned, when it increases, then you look what happened to this V. Okay? So based on that equation, based on that condition, then you give your comment, explain what happened to the V. Okay, any question? Any question, guys? Tak ada?
No, sir.
Alright. Kalau tak ada soalan, next, I mean, this is, which question is this? 19, 20, alright. The next question I'm going to look is the 14, 15, 02. Let me get the question first. 14, 15, 02. 14, 15, 02. Okay, sorry. Right. We look at part A first, Part A. Okay, so this is for 14, 15, 02. And during this semester, this is known as the test 3. Okay, test 3. During this semester, this question is being included in the test 3 question, meaning that we learn it later rather than we learn it later after we learn on steam plant, and then gas plant, then we go for this air compressor. That's why it's being put in test 3. Okay. Explain briefly what a reciprocating air compressor needs a clearance volume. What is the effect of clearance volume on the amount of press charge air induced? Sorry. So what should be your answer for part 1? For part 1, what should be your answer? Yes. Remember yesterday we discussed why do we need the clearance volume?
Mechanical comfort.
Mechanical comfort consists of two element, two aspect. What is the first aspect?
For valve,
For
Valve expansion.
valve
valve movement.
movement,
Valve movement. And also for
uh,
to allow
piston expansion.
To allow the expansion and contraction of different type of material. Okay, macam saya katakan semalam tu, our piston is made of aluminum alloy, and then the cylinder head and the cylinder block is made of cast iron. So both of these valve movement and for the expansion and contraction of different material, this will lead to the mechanical comfort. Okay. What is the effect of clearance volume on the amount of fresh air induced? What happened? What is the effect of clearance volume? The effect of clearance volume. No clearance volume. This is the condition of no clearance volume. Okay. With clearance volume. Okay, this is A, this is A, this is B, this is C, this is D. For clearance volume, this is C prime, this is D prime. It's asking for the amount of fresh air induced, which is this condition. So what happened? Without clearance volume, the amount of air induced is A minus D. With clearance volume, now it's become A minus D prime. So what is the effect? What is the effect? A, B, C, D. A. This is VC is equal to 0. Then we have our A, B, C prime, D prime, A. This is the case of VC is not equal to 0. Volume induced, for the case of VC minus VC equal to 0 is VA minus VD, which is equal to VS. But for the case of VC is not equal to 0, this is VA minus VD prime. Okay, so comparing, what do we have? I think it's clear enough kan? Saya punya penerangan ni. What happened to the induced air? Decrease. Right? Dia akan berkurangan. Dia akan berkurangan. Di mana kita dapati the VA minus VD prime is less than the VA minus VD. So what happened to the volume? The volume, okay, the induced volume will decrease. Right? So that is for part A. Next, we go to the part B. Let us look at the description given by the question first. We see the type of compressor that we are going to analyze. A two-stage single-acting reciprocating air compressor. Now it's given just now. The first yesterday we have did on the single stage. Yesterday we have today we did on the single stage double acting. Now we are going to look at this two stage. single acting. Okay, so that is the variation that we have of compressors. Single stage, single acting, single stage, double acting. Now we are going to go for the multiple stage, or in this case is 2 stages with single acting. A 2-stage single acting reciprocating air compressor delivers compressed air at 4500 kPa at the speed of 100 ref per minute. The free air delivery is 4.5 meter cube per minute, measured at atmospheric pressure and temperature of 1.013 bar and 27 degrees C, respectively. At the end of induction stroke, the air is at a pressure of 98 kPa and temperature of 40 degrees C. Wow! Now you be careful, huh? You see right now the unit of pressure does not consistent. It's not consistent. Here is given in bar, here is given in kPa. So be careful. The first stage compressor deliver the low pressure cylinder compress. The first stage compressor delivers the low pressure cylinder compresses air to 800 kPa. Apa ni? Apa disebut ni? The first stage compressor delivers the low pressure cylinder compresses bahasa nasihat ni. Tidak apa. Compresses air to 800 kPa. There, the air is then cooled to a temperature of 45 degrees C in an intercooler before entering the high pressure cylinder. The compression and expansion process follow a polytropic law 4.4 PV 1.28 equal to constant. The clearance volume for each cylinder is 4% of their respective sweat volume. Okay. Like what can you see right here? I can see this is an intercooler. Ada intercooler. 2 stage. And then I can see that at the induction stroke, the air is at pressure of 98 40. This is the P1 T1. And this one is 1.013 27. This should be our P and T. This is our T1. This is our P1. Okay. Now let us look. The compressor of double 2-stage single acting have to deliver for 5. This should be your delivery, which is your P2. What is this 800? Any idea, guys? What is this 800 for?
Intermediate pressure.
Pardon?
Intermediate pressure.
Intermediate pressure. Okay, this is our P. This is our intermediate pressure because it's discussing about the low pressure cylinder of the compressor. So as usual, we have the intercooler. And then the next question that we have to ask ourselves, is this intercooler complete intercooling? Is it complete? What do you think? Is it complete intercooling? Guys, is it complete intercooling? The air is then cooled to a temperature of 45. If you look at T1, what is T1? This is T1. Okay, T1 is 40. This is 45, meaning that the intercooling is not completed. Okay, it's not completed. Alright. So, right now, what are we going to do is to sketch our schematic diagram of the compressor. I'm not going to draw in detail. I'm just to put the compressor as a box. So this is the low pressure side of the compressor. This is the high pressure side of the compressor. We're going to have the intake right here, and then we are going to have the delivery right here, and then we have our intercooler. This is our P and T. This is our P1, T1. This is our P2, T2. Okay? And then our intercooler, this is our intercooler. Water in, water out. Let's say this is our P, I, T, I. This is our P, I, T, I prime. Now let's put all the values right here as far as the pressure is concerned and temperature is concerned. What is our P? This is our P. 1.01 here. Let me put that straightforward to KPA. 101.13 bar. T. T is 27 degrees C, equivalent to 300 Kelvin. Okay. And then we have our P1. P1 is 98 kPa. And our T1 is 40. It's 313 Kelvin. Okay. And then we have this, okay, this is done. This is, 4500. Yeah.
Why the pressure 101.13
bukan bar. Saya nak tukar kepada, I
KPA?
want to straight away KPA. Tak nak campur adukkan dia. Okay, thank you. This is KPA. So given in bar kan? So I convert in KPA. It's easier. Right. So right now we have the 40, now 800. Where is 800? 800. 800 should be your PI. PI is equal to 800 kPa. And we have our TI prime. TI prime is 45. 45 plus 273, 318. Betul? Check guys. Betul 45 plus 273. So 318, this is 313. And then lastly, we have our P2. P2 is given, we need the P2 to be 45. 500 kPa. Okay, what else that we have? Okay, the free air delivery is 45. So the free air delivery should be at P1T1, PNT. So this is our free air delivery, which is equal to the V dot, which is equal to 4.5. 4.5 meter cube per minute. This is done. This is done. The RPM N is equal to 100. RPM. Okay, this is done. This is okay. This is okay. This is okay. 98 okay. 40 okay. 800 okay. 45 okay. And the index of expansion and the compression and re-expansion N is given as 1.28. 1.28. Okay. And then the clearance volume for each cylinder is 4%. Meaning that we have 2 cylinders, right? Okay, 2 cylinders. So let us have this 4% as for the first cylinder. The VC is equal to 0. Here. VC is equal to 0.04 Vs per cylinder. And then again the same VC for the second cylinder is 0.04 Vs for the second cylinder. Sini 2, sini pun dah 2, tak boleh guna 2. I'm not going to use 2. Let's put the low. This is low. Okay. Let us define the appropriate symbol that we are going to use. Okay, this is for low. This is for high. Okay. Okay, guys. So I think I stop here. What you have to do is after this, you sketch the PV diagram. Okay, and we continue tomorrow, inshallah. Any question?
No, sir.
Question.
No, Doctor.
Let me take your attendance first before we leave. Okay, so that is your attendance. Tiba, any problem of setting? Okay tak, Tiba?
Yes, sir.
Any problem of in the chat box? Nothing, Okay, can you get it?
Yeah, actually today it is still the same, Doctor.
See the same?
Yeah.
Alamak. I thought I have unchecked everything before I enter.
Sir, it's need to check, sir.
Uncheck ke uncheck?
Can you check it, sir? Tick the boxes, right, to allow
Oh, look.
participants to check.
Okay.
Yeah.
Alamak.